So in this video, we're going to be looking at arrangements and permutations. So to begin with, we're going to start with an opening problem. So to begin with, in how many ways can the letters A, B, C, and D be arranged? So for argument's sake, you could just have A, B, C, D. You could have A, B, D, C, etc., etc. I want you guys to go through, write down how many different ways you can arrange it. Just pause it and have a go. So you can have, actually I'm going to pause it and so I've gone through and I've done 12 of them. So you can repeat this pattern. So I've done ABCD, then ABDC, and then I've switched it to ACBD and ACDB, and then I've swapped to ADBC and then ADCB. I've done the same pattern, but then done it for BC, and then the two combinations, BD, the two combinations, BA, the two combinations. And you can do the same pattern for starting with C, same pattern starting with D. So it ends up being 6 plus 6 plus 6 plus 6. There's 24 different ways you can arrange the letters A, B, C, and D. Now, when you get more letters, you do not want to be writing out all the different ways you can arrange them. I couldn't even be bothered doing it for all of these. But there is 24. So 4 letters can be arranged in 24 different ways. So there's got to be a shortcut. And of course, there is. So on the next slide, we're going to tell you that when you want to arrange, okay, we'll start with the definition of permutation. So permutation is an arrangement. So a permutation is an arrangement of a collection of objects when the order is important. Things like combination locks, all sorts of things when the order that you input the values is important, that is a permutation. So when we actually have a locker combination, it's not actually a locker combination, it's a locker permutation, because the order in which you arrange those letters or numbers on your lock is important. Now, when there's no restrictions, so imagine you have, we'll use this example as context. So imagine you have 5 different books. How many different ways can you arrange it on a shelf? Well, if there was 4 different books, we could do it, we just worked it out in the last question. If those A, B, C, and D were a book each, we could do it 24 different ways. However, what I want you to know is if there are n different objects, so whatever number, then there are n factorial different ways. Now, from last lesson, you should know what a factorial is. So for argument's sake, 3 factorial is equal to 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, etc., etc. So for our last question, we had 4 letters. So to find out how many different ways, it would have been 4 factorial, which is 4 times 3 times 2 times 1. And what is that? 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is still 24. And guess what? There are 24 different ways you could arrange those 4 different letters. So if we have 5 different books, how many different ways can we arrange them on a shelf? Well, the answer is simply going to be 5 factorial, which is just 5 times 4 times 3 times 2 times 1, which you could type into your calculator or do in your head. But I'm going to show you a shortcut way. So if you Google Desmos scientific calculator, you can simply type in 5, and then you can click the exclamation mark, which is above the 1. So shift 1, exclamation mark, and it gives you 120, which is awesome. So instead of writing out 5 times 4 times 3 times 2 times 1, we can just write 5 factorial. So there are 120 different ways of arranging those 5 books. Now, in our second example, we have 6 really competitive sprinters, all very similar times. How many different arrangements or permutations are there if I need to create a relay team of 4 people? So often when doing permutations or arrangements, I like to think of it using this method here. So if there are 6 sprinters and we have 4 spots in our relay team, 1, 2, 3, 4, Well, in our first spot, we can choose from all 6 sprinters. So there's 6 possibilities. Now in our second spot, we've already used one of the sprinters, so there's only 5 left. And in our third spot, there's only going to be 4 left. And in our fourth spot, there's only going to be 3 left. Now to figure that out, figure out the number of permutations, we need to multiply these numbers together. So 6 times 5 times 4 times 3. And that's going to give us our answer. So 6 times 5 times 4 times 3. So there's 360 ways, 360 different ways we could arrange those sprinters. Now, I'm going to show you this formula because it's part of the stage 1 course. So the number of permutations in the previous example we could find it using 6 times 5 times 4 times 3. Hopefully that made sense. Now, using factorial notation, we could have wrote this as 6 times 5 times 4 times 3 times 2 times 1. Now this times 2 times 1 was kind of pointless, not necessary, but that allows us to write out this whole numerator, top line, as 6 factorial. And then what we can do is we could have divided this by 2 factorial, and then the 2's and the 1's would have cancelled and we'd be left with just the black, which is what we wanted. So 6 factorial divided by 2 factorial. So we could have typed that into our calculator and got the same answer. So we could have done 6 factorial divided by 2 factorial. And we clearly would have got exactly the same, 360. And that's going to lead us to the formula that's in the stage 1 math methods subject outline. And basically it's this formula here. And it basically says that if we have n different objects, so in the last one we had n different sprinters, but we only want to arrange r of them at a time, and we only wanted to arrange 4 of them, then we use this formula here. So in our context just before, where did that paste? Let's paste it over here. So there were n different sprinters, so there were 6 different sprinters, and we only wanted to pick 4 of them. And it would have been 6 factorial divided by, now n was the number of sprinters, which was 6, and 6 take 4, which, what's 6 take 4? It's 2. So it would have been 6 divided by 2 factorial. And then that's going to give us, if you had 6 objects, 6 sprinters, and you only wanted to take 4 of them at a time. So that's the permutations formula. Now, I don't mind if you use the method that I used on the previous page, where it's just, 6 in the first spot, 5 in the second, 4, 3, 360, or if you use the formula, this one here. Formula is a bit more confusing. When you guys get up to making the video, I am going to expect you to use the formula at least once, so hopefully it makes a bit of sense, but for your general calculations, I don't mind if you just do it using this method. It makes more sense for most students. Now, how many permutations are there? Now we have 5 letters. So how many permutations are there on the symbols A, B, C, D, and E if they're taken 2 at a time? So basically this first one is basically just saying 2 at a time means in groups of 2. So in our first spot, we have 5. And in our second spot, we have 4. So there's going to be 20 different ways of arranging these letters in groups of 2. So for argument's sake, A, B, B, C, C, D, etc., etc. There's going to be 20 different ways that we can arrange them. Now, 4 at a time. If 4 at a time would be 5. So if we're grabbing 4 of them, it'd be 5 times 4 times 3 times 2. 20 times 3, 60 times 2 is 120. So that's how we can quickly work out how many permutations there are. So basically I'm saying A, B, C, D, A, B, D, C, etc., etc., etc. We also have A, B, D, E, etc., A, B, E, D, etc. I'm not going to go through them all, but there's actually 120 different possible arrangements. And different arrangements are just called permutations, where the order matters. Alright, a couple more examples. Now, in the Olympics, the final of the 100-meter freestyle has 8 competitors. In how many different ways can the gold, silver, and bronze medals be awarded? Assume there's no ties, dead heats. So obviously in the first spot, there's 3 different medals, gold, silver, and bronze. So in the first spot, there's 8. Second spot, there's 7, and then 6. So it's just 8 times 7 times 6. I'm going to use the calculator for that one. 8 times 7 times 6, 336. 336 different ways the gold, silver, and bronze could have been awarded. Now, we're going to look at some numbers. So consider the numbers or digits 0 to 9. So there's actually 10, including 0. How many 4 different passcodes exist if none of the numbers can be repeated? So again, it's a 4-digit passcode, 1, 2, 3, 4. Think phones. My phone's only 4. So in the first spot, you have your choice of 10 different numbers or digits. Now, if they can't be repeated, okay, once you've used all 10, then in the second spot, you can only have 9. And then in the next one, you've used up 2, so there's only 8. And then you've used up 3, so there's only 7 digits left over. And then again, you're going to be multiplying them together. So 10 times 9 times 8 times 7. Now, if this code was longer, the formula does become easier. I mean, it's easier to type in. But for 4-digit codes, in all honesty, this is the easiest method. 10 times 9 times 8 times 7. Whoops, that did not type right. So there's 5,040 different ways. Now, in reality, when I set a passcode on my phone, okay, it doesn't tell me I can't use the same number twice. I can. You can repeat. So, on your phone, if you have a 4-digit passcode, like I do, in the first spot, you can have 10 different digits. Second, 10. Third, 10. Fourth, 10. Another way of saying that, and you're going to be multiplying them together. Another way of saying that is 10 to the power of 4. So 10 to the power of 4, or 10, it's 100,000, 10,000. So there's 10,000 different possible permutations, okay? And usually your phone locks someone out after, I think it's like 5, 10 maybe. So it's very, very, very unlikely that they're going to guess your PIN code. There's 10,000 possible different permutations. But, you know, a bike lock, a 4-code bike lock, someone really wants your bike, they could sit there for a while. Sorry, this is dragging on. A couple more. This is the last one. Now, just a quick recap from last lesson. We looked at the multiplication or product principle, and we looked at, you know, if you're doing 2 separate actions, then you can work out how many ways there are of performing both of them, one after the other, in succession, by multiplying the number of the 2 different actions. So for argument's sake, ice cream store, cup or cone, different flavors, different toppings. So, you know, it would be 2 times 4 times 1 times 4. So 2 times 4 is 8. 8 times 4 is 32. So there's 32 total possibilities to choose from. That's the product or multiplication principle. Now, what we can do is we can combine what we've learnt about permutations or arrangements and the product principle. So for argument's sake, let's say you have a password and it said it has to be 7 characters long. Now, in the first 4 characters, there have to be lowercase letters, followed by 3 digits from 0 up to 9. Each letter and each digit can only be used once. So what we can do is the first 4 letters, how many letters are there in the alphabet? Hopefully we know there is 26. Okay, so in the first spot we can use all 26 letters. However, we can only use each letter or number once. So in our second spot, we're only going to have 25. Third spot, 24. Fourth spot, 23. we're losing a letter each time. And then our final 3 characters, digits. And again, 0 to 9 means that there are actually 10, and then they can only be used once. So 10 times 9 times 8. Now, again, the way that we would tackle this problem is that we can basically, if we're doing this first action, which is the letters, and our second action, which is the numbers, we don't add them together, we actually multiply them together using the product or multiplication principle. And then multiplying that all together is probably going to be a lot. That's why they always want you to use not only just lowercase, they want you to use capitals, symbols, and your passwords get a lot harder for people to crack. Wow, what is that? 258 million. So 258,336,000. 258 million. Oh, my pen's not working. 258,336,000 different permutations. And then as soon as you start adding in symbols, capital letters, your passwords get a lot harder to crack. So in saying that, I want you to have got this code breaker task. So it should be on daymap. And code breaker tasks work like this. Just a few questions. I think there's about 10. Mostly permutations and some arrangements. So basically, each question is going to have a number answer, and those number answers are going to correlate to words. So on the second page, you have words. So the first 8 questions, 5, 6, 7, first 9 questions is going to be some phrase with a question mark and then the answer. So I want you to have got the code breaker task. So for argument's sake, the first one, how many ways are there of arranging the word maths? Well, 5 letters, and it's just going to be 5 factorial because it's going to be 5 times 4 times 3 times 2 times 1. And 5 factorial is 5 times 4 is 20, 60, 120. So we find 120 up here, so it's here, and then it correlates to the word when. So this will be when. First word will be when, and so on and so forth. So have a go at that. Let me know if you have any issues. Cheers.